So now let's use the visualizer and see what kind of monstrosity results. So after running this line of code, I look in the visualizer and I get this crazy thing. All right, so let's see if this is the right tree. So this is maybe a little crazy, but let's do it. Okay, now P1, P2, P2. All right, I'm gonna do it. This may not be the most efficient way, but I feel like I'll get somewhere with it. So my KD tree has a root, and that root is the 0.23. Good, all right. And who is its right child? Its right child is a point, which is 1. Right child is 1.5. And its left child is 4.2. Well, that's close, but I have my children backwards for some reason. Okay. Well, let's just keep going. I think maybe I just have everything backwards. Let's find out. So then this right here is a dead end. My right child is 1.5. Oh, wait, sorry, I gotta go to the end of this thing. My left child is 1.5, my right child is, okay. So now, look at the next child, which is 1.5, or sorry, blah, blah, blah. So my left child is 4.2. Okay, so 4.2, it has one null child and one left child, which is 4.5. It has a left child, which is null, and a right child, which is 3.3. And then where's 4.4? It never got used. Okay, we have two problems. It seems like my tree is backwards, and also 4.4 never got added. Okay, so let's deal with that first issue. So if my comparison is less than 0. Oh, I see. I should be comparing the point to n.p, not n.p to the point. So I just had my comparison backwards. So let's try running this monster again. Okay, Java visualizer. I run the line and I get this. So the root is 2.3. Now the left child is 4.2, and sorry, the left child is 1.5 and the right child is 4.2. Okay, and 4.4 is still not getting used. All right. So now what I'm going to do is I'm going to use the debugger. I actually know what the error is now that I think about it, but I'm going to try and do it like I didn't know. So let's do a breakpoint right when, oh wait, no. We need to do a conditional breakpoint. So I'm going to go up to add. I'm going to set up a conditional breakpoint. I'll say condition. P.getX equals 4. I don't know if this will work, but let's try. P.getX equals 4 and P.gety equals 4. Okay, let's see if this works. So I'm going to run the debugger. We get to this point, and it worked. Okay, so P is equal to 4, comma 4. So now I'm going to step into my code. All right. If it's null, do something. Compare the points. Is comparison less? No. Is comparison greater? All right, so I'm going to say it considers the result of the comparison to be true. Okay, so n.rightChild equals add. So we'll step in. Okay, where are we? Node n. Maybe I need the visualizer. All right, where are we? So right now, n is pointing somewhere lower in the tree. Okay, so we are actually advancing. So let's compare. We go right. That's good. So go right again. Okay, so next up, n is pointing at this item, which is 4.5. That's good. So now I'm going to go past the comparison, compare 1, 4.5, we fell off. So 4.5, we were supposed to set the right child, but we're just returning. So why is that? Okay, it's a little strange. I do know the answer, which is that if items are equal, we need to go to the right. Okay, so this should really say if comparison is greater than or equal to 0, then we go to the right. Okay. So now, stop, and we will run it. Okay. So now, if I do the debugger again, from the very beginning, I'll turn off this conditional breakpoint. I am going to look at the visualizer. I step over that line, and we see that 4.4 is in the correct location. Now at this point, I have this vague feeling of unease, which has to do with the fact that if a point is equal, we really shouldn't be adding it again. That is, if I add 4.2 again, like this point again, we shouldn't end up with 2 copies of the point. So let's see what happens. Okay, so right now I'm getting the right tree for this example, which is a really good sign, but I got a little nervous thinking about this other case. Okay, so let's call this, let's make a private method. We'll call this private static void build lecture tree. Okay, so that's one possible little example I can run, but now I'm going to do something like build tree with doubles. Okay, so at this point, if I add the same point twice, okay, I want to see what happens, because I have this vague notion that I'm accidentally going to get 2 copies, and I should only have 1. Okay, so let's see what happens. So we'll call build tree with doubles, and we'll add a breakpoint here. So we run our code, Java visualizer, run the tree. Sure enough, okay, we got doubles, so that's not good. So we need to change something. So in the add method, I guess what we really need to do is, before we do anything at all, is that if p.equals n.p, like if the points are literally exactly the same, we'll just return. That's an easy way out of this problem. So now, return what? Oh, we'll just return n. So we don't change anything. We just return the existing one. Nothing to do. Is that really fair, though? I guess if p equals n dot p, we should say, no, that's it. There's nothing to do. If the points are equal, like there's nothing to change. It's going to be exactly the same, for sure. Okay, so if we try running this again, use the visualizer. Okay, after running this, we only end up with 1 point. Okay, good. So my fix works. That's a pretty subtle bug. Easy to slip past you, but I don't know. I saw it coming. But only because I was really familiar with binary search trees. Okay, so at this point, I think I have a pretty good KD tree insert. For the sake of making sure that the audio is good, I guess I'll stop this particular recording and pick it up in another long recording.